Okay, continuing on, hopefully quickly, with the various little bits and changes and things that I've been getting done in this marathon of waiting that's been going on. I know that the microphone's picking up a wind sound. That's the fan, the other fan that normally I would have off, but I need to keep this area ventilated and cool while the encoding that never ends continues. Still going. I'm wondering if it's going to hit the 24 hours mark. Well, I doubt it. I doubt it. Okay, now just a quick mention, I suppose, that one of the things I finally did, two things actually to do with TS Windows, is I managed to get these back under here. Before I couldn't put them here because there's some problem with source safe with one of the like a solution binding or something. I'm not sure what the wording is, but if something goes wrong, then it ends up that this thing isn't under the root, not the root, physical root, but what they call the root namespace of this project. And so that's why I couldn't move them here. But now these are under the root namespace of this project, and so are these. So they each have their own namespace, and they're each using the same directory, but those namespaces are different. Don't ask me why. If for compiling whatever, it doesn't matter where you put these things. There's a label, but source safe has its own special way it likes to deal with things. So the thing that I did, several things I did in here, but in terms of things I've been meaning to do forever and haven't done yet, I finally moved TS menu out of here. So now these are all only controls, and I still didn't know where to put it, so I just gave it its own file. Here it is. It's not a window. It's not a control. It's a nothing. It's like a kind of resource, basically. But you do get the feeling like it's an active sort of moving thing, and it is, but it's not on its own. It's not a window. It's part of, an extension of another window. So that was easy enough. In addition to that, I've actually been adding controls here that I haven't even used yet. That we already had, that works. I want to modify that. This is a new one, list control. That's the one with the report view. It's also called a list view if you want control. And I implemented many of these functions. I don't think I implemented that, but I definitely didn't implement that one. But they're all easy. It's funny. I found some of the implementations and copied as many as I could. And of course, the three or something that I used, I didn't get the code for, and I had to do it. They're not hard. The only thing about this class is, look at all these functions. I don't even know what half of them do. Use edit. You can use this with any kind of edit control, even a text, like a little text entry. I also added a rich edit control with all these functions that I don't know what they do. It's even got it returns rich edit, object linking, and embedded factory interface, something or other. But anyway, that's all just something that will come up naturally. So that's one thing I got done. And now I want to just go back to where I was. This the callback. Making a thing have a callback sounds easy enough. You know, you're reading a file and you read so many bytes at a time, and then you call the thing back. And essentially, it's not really that much harder than that, except that the way this was, there were several different cases and different. The reading itself, as it turns out, after adding this thing, comes down to either one of two functions. So that's a good thing. Like this function here now has 1, 2, 3, 4 arguments, right? Now the copy function, which is now just general copy, similar to before, it had, in addition to those ones, it had another 2 arguments. I think it had a bool too, for whether or not to toggle. In fact, it must have. General copy, general, everything's, I think this is not, go back further. That's the hard drive, this is so safe. Oh, this was in the wrong file. That's right, that's right. So I can't really compare because I had this reading file thing somehow wound up in the strings file, so I had moved it for longs. But anyway, when you have a function and suddenly it's up to 6, 7, 8, or 9 arguments, then what you do is you invent a struct. Instead of having all those arguments, you invent a struct, and then you fill in the struct. So that's what I've had to do eventually. Converted all those new arguments. There's this one, and there's this one are extras, and there's just too many to not have a struct. So what is this struct then? I'll get to that in a sec. First, let's have a look here. Well, the beginning part of the read is just trying to determine if there's an encoding, and if it does find a valid encoding, if it doesn't find a valid encoding, it's going to call this detect encoding to try and figure out from the data. And so I've got to actually build one of those structs in order to do that. We have a pointer to file. We have an output string, right? In this structure, I've made that a pointer to a string. A struct. I didn't want to. It has to be a I need to pass a reference to the string that was passed in here, right? For it to fill up. Not. It doesn't return the string or anything, and it's best to just don't use a reference in the structure. Just use a pointer. It's easier, and you don't have to make a constructor, and it's not complicated. Then there's the file size, which has been computed, and I didn't want to compute it again, so I put that in. There's whether or not there should be any toggling. In this case, that doesn't count. Now there's this new callback function, callback function pointer, which I'm not putting any PFs in front of this sort of thing, but maybe I should for clarity. I think the pointer to function is really a misnomer. Functions are pointers, right? There's no such thing as a reference to a function. Okay, and bytes per call. Bytes per call is part of this structure. Why is it part of that structure? Oh, it has to be, yeah. Once the value, the number of bytes to read before the next callback, once that's known, it has to be maintained. And so that gets filled in fact, on the first call, right? I call this callback immediately to find out what the value of this is, because the function doesn't tell me, and it's not passed in anywhere, so I just call it and let the user fill that in. All right. So then I'm going to add that to the structure because it's been computed, and the other argument. And now this goes into the detecting thing. Well, how this is implemented is not so important. Well, I'll just show quickly that regardless of the logic, whether the logic is right or wrong or good or bad, in the end, it either boils down to general copy of wcar, general copy of wcar, with a different info. I have to make a new one because I passed this in as a constant ref. I don't know why. There's no need to make it constant. But anyway. So general copy, or invalid, or general copy car. So that's it. So if we can do the general copy, then we're done with that problem. And that leaves just one other problem. The general copy is in fact easy, so I didn't start with that. I started with the difficult one while I still had the energy to do it, and that is UTF-8. See, previously, here's the beginning of the UTF-8. Previously, I just read the whole thing in it once. It's not that it's that hard, but it's messy. It's not going to, it is not going to. Forget that. So if I read the whole thing in at once, that's easy because, the way that loop works. Here, this UTF-8 decode, that's easy. Once you've got the beginning and the end point, you just keep going around and round and round until you're done. But now I can't do that because every now and again I've got to call back. So it's got to be broken up and read in chunks. I chose this size since it's the natural size. It won't read any less than this anyway. And now I'm going to keep track very carefully of where I am. So first I skip past the preamble, so this is the amount of cards in the file. Now the size of the buff is some, either whatever's left, if that's the smallest, or the size of the buffer. I read that in and subtract the number of cards in the file, subtract whatever I read in. That's easy to understand. PB data is where we currently are in the data buffer. and end is where the data ends. Not necessarily the end of the buffer, because this could be smaller. Clear out the screen. Now this is something that comes up in a minute. You'll see bytes read since last callback. Now this is the just what it says. Last callback meaning calling to the caller. The caller is called back. Function. I could do a test here. If callback is null, then don't bother with this. But it's already looking pretty ugly, so I figured just pretend that it's always necessary. Okay, now skip this for a minute. Just go to this part. Sorry, this part. This here, this header part, is just kind of fixing things up after the last read. There might be some left over. Now I might be off by one in this, but I think I'm not. Now I need to find a place to end that's what I call safe. The end, this end is the end computed in the regular fashion. Where is that computed? It's either here or here. Okay, it's the same pattern, right? It's always buffer and buffer plus some amount. That's, now since it's UTF-8, it's possible that it might take up to 3 bytes to decode one T car, right? So I don't want to go all the way to the end, because I might be at, so let's say I'm at position 4, it's 4096, so 4095 is the last index. Suppose I read in starting from 4095, okay, meaning that there's, that's the last byte. Well, then this decode thing is just gonna return it's just gonna return that byte and not try to do anything, because it can't read any more data, so it's got to terminate, right? Even though if we had more data, we could work it out exactly. So that it would be bad to pass in 4095, and similarly for 4094, because 2 bytes might not be enough. So, however, 4093 is safe, because at worst that will take us right to the end of 3 bytes remaining, right? So I take the endpoint. Now cards in file is the number of characters remaining to be read afterwards from the file. If there are characters in the file to be read, then I'm going to subtract 2 from the end. Now I know that's also safe, because if there are cards in the file, then that means we've filled up the entire buffer of 4096, and we'll certainly be able to subtract 2 from that. Otherwise, the file's empty, so we'll just go straight to the end. This end really is the end. Hopefully that logic is correct. And then just do the regular decoding up to the one or the other endpoints. This is still the same calculator. No, it isn't. Yeah, I gotta use this one. No, No, this is correct. Because this safe end is not the end of the data. It's only the end of as far up as far as I'm going to allow this thing to read. However, the number of bytes remaining in the data is given by this difference as usual. And so it might advance, the end point might advance past this safe end. It might even go right to the end of the buffer. It's possible. Now, if there are some characters in the file, and if the bytes read, okay, now we're checking to see if we need to do a callback. Bytes read since last callback. Now, where is that being computed? I don't think I'm computing that. See, it's good to go see. Oh wait, no, it's being incremented here. Yeah, it's already been it's been computed. That won't be true. That won't be true. So it'll be 0 initially, which is true. 0 is no, but then it should start out as 4096. Oh, it is. Okay, that's correct then. So we have read the size of the buffer, right? And so it doesn't start out as 0, it starts out as 4096. Now, if that is bigger than the value specified for cause a callback, we do the callback, and it's bytes read, which I'm just computing by taking this difference, size of the file minus the amount remaining is the amount that we would have read at this point. Size minus remaining is equal to read. Read plus remaining equals size, yeah. Then the full size of the file, and this thing, in case it needs to be updated, and the user data. If that returns false, then I'm setting PB data equal to end, and I'm breaking out, and the only reason for setting that is to make this assertion not go off, and I don't want a false return. We're just going to stop. Now, after that step, remaining bytes last. Oh, I see. Yeah. Now this number might be non-zero if we didn't read all the way to the end of the buffer because of this condition. And so that's the real n minus where we really are, and it typically ends up being 2. Okay, if the file is mostly ANSI, this will be 2. So if there are any cards remaining in the file, or if there are still some bytes we haven't dealt with, then we continue the loop. Back to the top, and that's where it just starts to make some sense. If there are some bytes remaining, what we're going to do now is take the remaining bytes and put them at the head of our 4096 buffer. And now I'm saying, and indicate that the buffer has been exhausted, but keep this value non-zero for use in determining where the next read begins. Okay. So this is where it's a bit convoluted. So we copy those. It's kind of silly. I don't have to do it. There's only 1 or 2, right? But whatever. In general, maybe you had a different span. String end copy to the start of the buffer, starting at PB data, which is going to be near the end of the buffer, this many bytes. So we'll take the tail and we'll put it at the head. And now these two are set equal, so we're at the end of the buffer. So that's how it's possible for this to be true once at this part in the loop. If this is true, that the current position is the end position, or at the end of one read. Now, and if there are still characters remaining in the file, the only possible way that can be true is from this scenario. So in that case, the number to read is simply the minimum of however many we have left, or however big the buffer is minus that number that I didn't zero out, and that's why the comment here that determines how many bytes, the maximum number of bytes we can read into our buffer. Read it in however many bytes, subtract from the amount in the file however many we read. Right? Size to read is not the size in the buffer. The size in the buffer is size to read plus this. If it happens to be non-zero, it will be 1 or 2. Increment, now this doesn't even have to be 100% accurate, that's just for the callback, but it is accurate to say that the bytes read since the last callback would be plus equals. I see, now why am I saying plus equals? Oh, well, I guess it's an incrementing thing. And it would have already included these 2 bytes, so it doesn't matter so much. Now the beginning is where it always is, and the end is this. This could just say 4090. No, it can't. Sorry. Size of is read plus remaining. Typically it's 4096, but it might be less. On the last round, it'll be less. Now, if cars in file is 0, you know, it's possible. Is it possible? If this is bigger than 0, I think I can assert that this is 4096. Really. This is going to be 4096 because there are characters still in the file. Right? And the way characters in files is adjusted is by this calculation involving num elements. The only time when this becomes 0 would mean we would have had to fill the entire buffer up. So I could probably just as an assert, you know, the logic I believe is correct, and I might be wrong about this, but it certainly doesn't hurt to make an assertion. Oops. That seems to make sense that this only happens when we get a full read. Otherwise, if it's not a full read, then we're on the last read. And okay. And then we break. But this is only like 1 or 2. Oh, so this is false. Sorry. I see. It could still be the last read, right? There are characters, let's say there are 2,000 characters left in the buffer, and there are 2 remaining bytes. This gets set to end from the last go. Cards in file is non-zero, it's 2,000, and so this is not a full read necessarily. However, if cards in file is 0, that means that the last read was of this type, not full. And all that leaves us with then is just the 2 remaining bytes that we haven't dealt with yet. So to keep things simple, I just run through the decode of the last 2 bytes here. Okay, now they don't have to be ANSI, it could be. Those 2 bytes might represent only one Unicode character, so I've got to do the loop and then break. You see how complicated all that is? Now, it's calling back to and it's breaking when the callback thing says false, so that should work. Now going to the easy case is general copy, the only other possibility, where we start with this info, get the file pointer, I turn this into a reference so that I didn't have to change names of things. Similarly here, toggle, also that was a parameter before, bytes per call is new. Now that's okay. This asserts that if it's Unicode, then the file size should have an even number of bytes. Now I don't think I should really, it's returning, I don't know if I should return on that. It could be Unicode with a mistake. But anyway, tough luck, malformed data. Alright, so now just setting up some variables, characters, right? T card. Now it's dealing with T cards to simplify. None read yet. T cards in a file is the total size of 1. Number of T cards remaining is T cards in files minus already read. This is written this way to emphasize the calculation, which is going to be down there. And again, this bytes is last callback. Now I'm using a buffer, again, of size 4096, and I'm adding 1 extra to my buffer to act as a null terminator in the case of a full read. Alright, now the number of characters we should read. Oh, by the way, if you can see, if the size of T, I should say size of T, not T car. This is a template thing, but if T is either T car or car. So if it's 2, right, then this would be 4096 divided by 2, but each element is 2, so it ends up the same size. 4096 plus 1 T's, right? So it would be 4098 in the case of wide cards. Okay, read in the minimum of the num elements minus 1. That's simply the full size buffer, not including this extra, or however many are left. Do the read, assert everything reads okay. This here guarantees that this is the null term. This is our null terminator, and we know that that's safe because we subtracted 1 here. If toggle, then do the toggle thing. Toggle means change the endianness. Now we append to the string buffer the entirety of the buffer that we just read. Increment number of characters read to however many we just read. Nothing to that. Increment number of bytes. Now this is in bytes, not T cards, so this has to be, it should be T, not T card. So yeah, T. And all of these should be T. Okay, so the number of bytes we read is possibly double the number of T cards. If the number read is the number remaining in the file, return true. If the number of bytes read is more than requested for a callback, take the callback, call it with amount read. I don't know if this is correct now. Size in. Oh, this is total amount read, not just this time around. Total amount read, total size, and the same as before. If that returns false, we break, and a warning will be printed, and we still return true. And we reset this to 0, just as we did before. Subtract from number remaining. Compute the number remaining by taking the total number of characters in the file minus the total number of characters we have read, which was incremented here. That's the same computation as here. So that's it. Now let me see. I've explained that whole thing. It only took me 37 minutes. Alright, now I got this U-test, and what I'm going to do is I'm going to open up a big file, and I'm going to make a callback, and I'm going to print out percentage as it's reading. So this U-test, I invented a U-test specifically for common. This is UT common for when I add little functions to common. This is the place now where I'll go and test them, because I find that I've always got like 12 different tests running in this thing. I need another spot for little things. Okay, well, I won't run through that test. I haven't done it. I'll do that, and if it works, I'll just show you it running. You can see that I haven't added anything yet. I was still the last test here. I created a file that I should not be able to open. I wanted to check my system error string. In fact, it works. Well, it works in this case. I made the file read-only, and I try to open it for writing, and the error string comes back as you can guess what it's going to say. Or at least something similar. So anyway, if that was working and done, then the next step is to apply that here and make a percentage bar, which means more work, adding a new control, a percentage bar control. They're not hard to make, and they're quite nice to indicate the progress of a file read. second. Okay, here we go. See, I like my new wallpaper. Oh, it's not it. Hang on a second. Okay, sorry. Okay, here this runs, and it says what you expected. Permission denied. As far as the wallpaper, if you didn't see it in one of my numerous announcements, I made a new one, taken from an already seemingly perfect thing. And I don't know if it's better or not. I don't get much feedback, but really you need to see the two of them. It's this one here, but you're gonna get a. Wait, I have them side by side. Not there. Picks. Whichever one you see first, you're probably going to take as the best, because it's one of those types of things that you love the first thing that you see. But go with the original first, and take my chances. The original name of this, by the way, it's a beautiful, beautiful picture. Where's the original? Here's the original. Beautiful beauty, colors, dreamer, dress, eyes, face, female. I can't see it all. Hand, lips, lovely model, people, photography, pretty, sensual, she, woman. But anyway, you notice how it says eyes there. Well, my problem with this, as wonderful and beautiful as this is that, and she does have nice eyes, but they don't really stand out. So I tried to see how I could adjust it to make the eyes stand out more. And I wasn't worried too much about the surrounding bit, which I figured I could fill in. But anyway, this is my alteration. So you can see that what I've done is it's greener, right? The whole thing is greener. It's a shift towards the green, and her eyes are kind of a greenish color. And I reduced something they call highlights. How it determines what's a highlight, I don't know, but it's like here. This would have been a highlight, and this here, the things that are, I guess, brightest, and added, shifted using the color wheel. The famous color circle and bar, color circle and square. Imagined how to sort of greenify it a little bit. Because her eyes are green, so I thought that might add some more green to her eyes, and it does. And it adds more green to her eyes than it does to the surrounding bits, so I find that her eyes are more prominent here. They stand out. Here they're nice, but here to me they stand out. And if you look at it, the way this, assuming it is a real person, and it doesn't really matter, but The focus of this image, I think, is on the eyes. Like the place where the sharpest focus would be, it's in around the face area. It's more and more blurry. It's not a very, the depth of the field of focus, or whatever they call it, is short, right? So by the time you get to the neck, it's already starting to blur. So it's only sharp around the face area. So the camera is focused at the face area, and I would guess that it's approximately the eye. So this is really where the focus is anyway, of the picture. The whole picture is focused here. And so that's why they're sharp. The corners are sharp. It's true. Whoops, it's true in the original too, but it's more so here. At least it shifts the focus more towards the eye, I think. Anyway, so I show you that. All right. Well, hope you enjoyed that. Little interlude into the pain of getting everything, trying to get everything right for one little feature. But anyway, all these things do, it doesn't seem like it, but all these things do have their payoff in the future. I started with nothing at the beginning of this tutorial series, just with the debug program, an assembler, and now I've got a whole library full of useful functions, and the tools that I've made I prefer to use over the ones supplied by the operating system. I love my old notepad. It's great. All right, see you.